let's use WinPs. Now, if you do WinPs GitHub, the first hit takes you here, right? And this is pretty awesome. You think, oh, this is cool. You know, we got some EXEs, we got some BATs, .NET 4.5 is required. And if you click into these, you'll see some solution files, which isn't an executable. So you might be wondering, like, how do you run this? Now, it turns out you actually have to compile this in Visual Studio, which means you need to, download Visual Studio, set that up, and you could do that. I actually have a Windows host here, and I can walk you through that process. But it's a lot easier if you get it pre-compiled. And so what we're going to do is we're going to go to a relatively new collection called Sharp Collection. Sharp Collection, GitHub. And this is just a collection of applications that were written in C#, and it pre-builds them in all of the required .NET framework versions. So, this is really nice because it's an automated system that just, checks for any new commits against any of the major C# repositories, and it just adds them into this repo. So we've got stuff for like, Sweet Potato, which is a local privilege escalation for Windows boxes. We've got Seatbelt, which is kind of like Power Up and Watson. And it's also in the same category as WinPs, right? This is local Windows privilege escalation based on misconfigurations. And then there's like Safety Cats, which is kind of like Mimikatz, but a little bit better, and a bunch of other things. So let's go ahead and find WinPs, but before we do that, we need to know what .NET version we're at. .NET version command line. So we can look on the registry, and it looks like if we go here, we should be able to find it. So let's copy that. And we can actually go into the registry like this. So you notice I just CD'd into HKey local machine. That's because PowerShell has this thing called providers, which allows you to navigate various data structures just like your local drive. So this is really, really cool. And so I'm in the HKey local machine provider. Let's just backspace all this out. That didn't work, so maybe it's not there. Let's try this one. Nope. Let's see, Microsoft, that works. Let's go big, Control AZ, Control A, left bracket, / net. So it is just net framework setup. And there we go. You see we already have version 4. But we probably just need to CD into NDP. Yeah. So we're at version 4. And we can get the exact version here, 48033761. So really all we need to know is that we're at version 4, because now if we go to Sharp Collection, we can grab that version. Now we don't know if it's a 64-bit or 32-bit. Let's just try a 64-bit application for now. Copy link location. Control AZ, sudo wget, Control Shift V, enter. Nice, we've got it. And let's just make sure we got it. That's not right. It says it's an HTML document. If we actually this, you'll see it actually is an HTML document that's named as .exe. So let's fix that. Yeah, we want the raw link. Right click, copy link location. That's why it's always good to verify what you download with the file command. Sudo wget, Control Shift V, enter, ls. All right, so what happened here? You know what? We probably needed this link. Yeah, this raw link still isn't what we need. We need this download link here, because if you look at the status bar, you see it actually ends in .exe. This one ends in raw equals true. So Live and learn. Copy link location. Let's remove the other ones. We've got WinPs, file WinPs, and this is a 32-bit executable. Well, it's a PE32. It's actually 64-bit. But the point is, it's a .NET assembly. This is exactly what we need. And our web server is still listening out of this directory, out of the home boxes control directory on port 80. So back in our shell, we should be able to get this with wget, which is an alias for invoke web request. And this will allow us to download this file, 1410. Now, before we do this, let's make sure we are in the right directory, because if we run WinPs from a restricted directory, it might get blocked by AV. So we want to make sure we're in the right directory before we try to run this. Let's go back to Hector's directory. Let's go back to documents. All right, so wget 1410 winps.exe-o winps.exe. Nice. Here's WinPs right here. And you can see the HTTP request went through. So now we can run it. See what we get. All right, WinPs just finished. Control AZ. It took about 1 minute, maybe a little less than that. So I see a lot of red, and that's good for us because it means it's usually something we can grab or exploit or abuse. So we've got WinPs. Let's start. So red indicates special privilege over an object or something is misconfigured, right? That's generally what we're looking for. Now, just to start, you can see that there's no PowerShell logging enabled, right? So we can use PowerShell all day on this box in abusive ways, and it will not be logged. So that's really good to know. We also notice that there's a history file called console history, right? This file is interesting because it's kind of like your bash history. If I do Control AC, I do, let's see, if I go to cd, my home directory, then I do cat.bash history, enter. You see, this is a catalog of all the commands I've been typing, right? This is on Linux. Well, on Windows, there's something similar in PowerShell, and it's called this console history, right? So this might be interesting. If we can see what commands the user typed, we might get some clues on what we need to do, right, to compromise this box. It could be clear text credentials that were entered as arguments to specific commands. There's a whole bunch of goodness that can come out of that. Let's just continue to scroll down. By the way, Laps is not installed, so that means if this is the local administrator password solution. So, if we had multiple machines, if this was a real engagement, you had multiple machines, and they were all using the same local administrator password, then you can use that to pivot from one machine to the next. And here's some other things that are not enabled. That's going to definitely help us in our exploitation of this machine. You can see here, we can write, we can actually create directories on the C drive, and there's no AV detected. That's awesome. So we can basically work under the radar, right? And we keep going down. Basically, I'm just looking for the red. I have access to the home folder. I already knew that. Let's go down, let's go down. And this is interesting. Modifiable services. So I can't modify a service binary, right? But I can modify a registry location is what it's saying. So this is interesting. A service typically runs as NT authority system. And it's mapped to a binary that exists on the file system somewhere. If a standard user has write access to the folder containing the binary, they can possibly replace it with a nefarious process, restart the service or restart the box, and then if that executable happens to be interpreter or some other evil binary, then if it shovels a shell to the attacker, the shell will reach the attacker with the privileges of the service account that is running the binary, which means the attacker would have system access to the machine, which is just like administrator, it's God mode, right? We don't have that ability, but we can write to the registry. And that's what this lecture is about. You can see here, Hector can take ownership of all these registry keys. And we're going to confirm this using Access Checker, which is a sysinternals tool. But this is very, very interesting, right? Because if we can modify the image path of a binary in the registry, we might be able to gain vertical privilege escalation that way. Let's keep going down here. Let's see, DLL hijacking, nothing there, nothing there. Yeah, nothing else is really interesting here that I'm seeing. This file did exist, unattended.xml, but you can see the password was deleted. Sometimes you can find it in these unattended files, which is just a way for network administrators to automate the deployment of hosts. And when you automate things, sometimes you need to put passwords in so things happen automatically. And remnants of it can be left behind, which you can retrieve from here. But it's been removed. But there we go. So let's go ahead and do git content on that file that it showed us. So the console history, these are the only commands that were executed. That's kind of interesting. Let's go ahead and, before we look at these commands, let's go ahead and get access checker by sysinternals on here so that we can corroborate what we're seeing in WinPs. I always like to use multiple tools to confirm what I'm seeing. Here we go, sysinternals. Download access check. Copy link location, go back here, sudo wget Control-Shift-V. All right, sudo unzip, access check. All right, so now we've got this file in the root of this web server, which we can now pull from Hector's machine. So let's do that. IEX, invoke web request, 1410, access check. Let's run the 64-bit version. Use basic parsing. Wait, what am I doing? That's not what we're supposed to do. We're going to use wget to get it. And the output is going to be access check 64.exe. All right, so it looks like we have the request here. We didn't get our prompt back. All right, so it looks like something broke. Now, you might say, oh no, we just lost our shell, right? No worries, right? Now, I'm glad this happened because I want to show you how easy it is to get it back. Listen on port 443. Go back to burp. Control space. We're back here. And we can just tab up to get everything back, right? Username equals Hector. Hostname equals fidelity. Password to a secure string. Credential object is there. And then before we run the invoke command, we need to make sure we are listening on port 443. Again, to get our privileged shell. And we go ahead and execute it. And now we're back in business with Hector. Dash out file. Okay, we saw the request go through. This time the shell didn't hang. If we do dir, we see it, and can we run it? I think I have this slash going the wrong way. Yes, we can. So, what do we want to do here? Well, we just want to verify what we saw in WinPs, right? With the registry rights. So let's see. Let's do a /registry. So we run access checker, then the account name, and then we have all these flags we can run. K is related to the registry, so this will show us name is a registry key, so we can then specify a specific registry key. We'll just get that key from WinPs. W, show only objects that I have write access to. I can recurse and suppress the errors. That looks like that would be good. And then of course I need to put the registry key in. Well, that's the one we got from WinPs. So we'll just put that in. Yeah. So again, we're getting pretty much what we saw from WinPs. Read write control. RW read write. Hector can write to this registry, can write, to all these. So this is going to be interesting for us. So let's go ahead and do some stuff here. First, what I want to do is I want to get all of the registry keys that are relevant to this. HKLM, let's go to system current control set services. I think I need the star at the end to see all the services, right? So I just want to look at all the services on the box. Here we go. Let's save that in a variable. We'll name it, services, right? So now we can just type services and get a list of all the services. So these are all the services on the box. Now, I want to make sure I only get services that are running a system and that I can restart, right? Because that's what we're going to need. We want the service to run a system so we can escalate. And we need to be able to restart it so that we can, execute our exploit. So what can we do to do that? Well, let's go ahead and start looking through some of these fields. Okay, here we go. Looks like the object name field contains the account that the service is running at. And the service name is PS child name. So PS child name, wsearch is a service running as system. And it started as 4. So we need to get a list of all the service start numbers. Let's do that real quick. Service start type values. That looks better. Here we go. So we want manual. This service does not start automatically and must be manually started by the user. So we want type equals 3 for start. All right, so let's build this query out. We can take services and we can pipe it to where object. This is kind of like a filter. And in this block, we can say, we only want the services returned that meet this criterion. The object name is equal to local system, right? By the way, this little crazy thing right here, this just means take the current object passed along the pipeline. Here's the pipe. This is called the pipeline. We're passing the results of this object into this object. And this actually literally says this object, the current object. Take this property from the current object, which is object name, which contains, the account that's running the object, and only return the services that have an object running its local system, right? So all these should say local system for the name. For example, we did like a select object name. Yeah, local system, right? And these are all the services. But we also want to make sure that the start type is manual. So in here we can put, again, the current object, start, is equal to 3, right? And that's what this is right here, the start. So these are all the services running as system that have a manual start. So we can actually set this to like, let's say is hackable. Right, so now we can say is hackable and get a list of all those. Now, this gets interesting. How do we determine our permissions, right? How can we determine, we can write to these services, right? But we need to make sure that we pick a service that we can actually restart. There's a difference between writing to the registry and restarting a service. Those are two different permissions. So the way to find that out is by using a built-in Windows command called the SD show. So if we go here it is. displays a service's security descriptor using the security descriptor definition language. This will tell us the permissions on the service. So let me show you something. Here it says you can do something like this, right? Let's try this. If we do SD show, let's pick a service here. This one, WUAU serve. Did not work because it's trying to convert this into a commandlet. So let's run it like this. Let's run command with the /c and then try it that way. There we go. So what we have is this really, really complicated looking security descriptor definition language. And what this means is this is a discretionary access list, okay? And this A means that it is an accept. It's an accepted access control list. Each of these values in here are pairs. So this is one pair. This is another pair. This is another pair. This is another pair. Right? They're all pairs, and they all mean something. And the stuff at the end means something too. This means authenticated users. This is built-in administrators, and this is system accounts. How do I know this? Just Google it, right? If you go to like SDDL, stop, start, restart, permissions. Let's try this one. Yeah, so this is the one. So we're this again. You can look at the permissions. It shows you this, and you can read up on this. But you see here, RP means service start. That's what we want. These are the other ones, like authenticated users, system. So we want everything that has this RP because we want to make sure we have permissions to start the service, right? So we want this. Every service that has AP and is for authenticated users, because we are an authenticated user. We are not a built-in administrator, and we are not running a system. So how can we do that? Well, let's see. Let's look at this is hackable thing. Again, what do we call it? Is hackable, right? If we look at the child name, these are all the services, okay, that are running a system and that are set to manual. If we could create a loop to loop through all these services, right, then we can look to see, we can basically pass that service name to that scsd show command and then do some regex to see if we have that RP flag there, which means that we also have permission to restart it. So basically we're saying I want to find all services running a system that are set to manual and that I can restart. Let me show you what I mean. So I can say for each, let's just call the variable on each iteration service in is hackable.ps child name. What are we going to do here? Well, we want to print out that SDDL command, and we're going to save it in a variable called SDDL. We're just going to say cmd /c scsd show service. Right, we're passing the service on each iteration to this command. It's going to be saved in this variable. And then we'll just run a little if condition against it. We'll say like if SDDL is a match for some regex, we'll fill that in a moment. Then we can just basically say print out that service, right? So what are we going to do for that regex? Let's go back up here. And let's grab that SDDL output that we did earlier. So I actually can't go back far enough to get that command. So what I'm going to do, we'll grab this, right? So we'll go in here. We will click copy. And then we're going to go to regexer. I'm going to show you how we can build regex to select this. So this is a great site for building regex. I'm just going to go and delete everything out of here and delete everything out of there. Okay. So here's the thing. We just want to get, we want to search for RP, right? And any number of characters until we get to semicolon, semicolon, colon, semicolon, AU. So if we did something like RP, these characters all look like they're A through Z capitalized. So we can say character class A through Z capitalized. So we can say any number of characters A through Z. That's what the star does. And the question mark makes it optional. And then what we want to do is we want to look for the 3 semicolons and AU. So that's what we want to match right here. See how it matched this one, but it didn't match anything else? Because remember, this is built-in administrator. This is system. We don't care about those. We only care about this. So this works. Let's grab it. All right, let's press enter and see what happens. If we have any typos, yes, that's what we want to see. So let's save that as a variable, Control AA. We'll name this can start. So these are all the services we can start. So let's just start with this one since we were looking at that one earlier. Let's do get item property. And actually, let's see what we can type with this. Let's go back into PowerShell in the local box. Get help, get item property dash parameters star. So really what we only need is just, I believe, just the path. Yeah, specifies the path to the item. So we just want the path to this item. So HKLM system current control set services WUAU serve. All right, let's make this big. Control AZ. Here we go. You notice the image path here. So our goal is to replace this image path with an arbitrary command and then restart the service since we have restart rights to this service. So let's try it. Let's go back here. Set item property. And let's see what parameters we can do with set item property. Get help set item property parameter star. Let's see. Name specifies the name of the property. Okay, we want that. What name do we want? Well, we want, let's make it big, Control AZ. We want this image path name. That's what we want to set. So we can say image path. And I believe there was a value. Let's go back here. Path, type, value. Specifies the value of the property. Yep. Control A, right, Control AZ. And let's do value. And let's just set it to foo. Right, just to test that we can actually write to this path. Then let's do get item property. Bam. We can write. Now the interesting thing here is that you're going to actually discover in this host that there's a job that runs that continually overwrites this image path. So we only have a few seconds to essentially host our netcat payload on our local box, download it to the victim machine into a whitelisted directory, which bypasses AppLocker, and then execute the binary. Because if we wait too long, and really it's just a matter of seconds, then this value is going to be overwritten with the original image path, and our shell will die. We're also going to discover after we pop the shell, we're going to have to quickly create another shell from that shell in a new process so that we can have persistence on the box. And I'll show you what I mean in a second. So let's go ahead and do this. First, let's make sure that this is still here. Still set to foo. All right. So let's go ahead and move into our whitelisted directory. Let's see, Windows, System32, spool, drivers, color. So if you Google this directory and we go to, let's leave this page, AppLocker bypass, put that in. Let's type in like GitHub. List of generic methods for bypassing app blocker. Here we go. Now, what is app blocker? This is application whitelisting. App blocker has been with Windows for a while. Yeah, so it helps you control which apps can be run on the operating system. So it's really good, of course, when you want to like basically say these are only the approved apps. Anything other than this won't be able to run. This works because these directories are typically permitted by app blocker. So if you can get something bad to run out of these directories, then you can potentially bypass app blocker and float under the radar. So that's what we're going to try to do here. First, we need to get netcat hosted on our local box. So let's do that. Let's exit this, locate nc.exe. We found it, let's see, here. Let's grab this one. All right, so we've got netcat hosted here. That's sweet. So let's go back here, Control A, Z, and let's run wget again. And we are going to actually save it as iexplore.exe. Why iexplore? Because that is the process name for Internet Explorer. Wow, I cannot type. Yeah, Windows Internet Explorer by Microsoft, right? So we're also trying to bypass, any static strings that might be in place by masquerading as a benign application. Let's do that. Now we have iExplorer, but this is really netcat, right? So now we've got netcat. Let's go back. You're going to notice if we try to run this again, now it shows that it's been overwritten, right? So we only had a few seconds to get this done. So we need to overwrite this again, but this time we need to overwrite it with our netcat payload. So this is what we're going to do. Let's go to set item property. And instead of this, we're going to put in this. Control Shift V. Copy, Control Shift V. And what are we going to do here? Well, we want to connect back to our machine, 443, and we want to shovel PowerShell to us, right? Then when we say get item property, when the service restarts, it should cause netcat to connect back to us on port 443 and send us a PowerShell shell. Control AZ. Let's go back over here, sudo rl wrap 443. And let's see if we can do this. Start service, WAU serve. And nothing happened. And if you notice, everything got written back, right? And Control AZ, we need to do this from that HKey local machine directory. So if we go back here, let's go back up. Let's go back into this directory. Right, so we want to do this again and then get the item property. See, now it looks good. Then we want to do the start the service. Control AZ. Do we have a shell? Still no shell. Now, why is there no shell? Control AZ. Let's see. Did I get the name of the binary right? iExplore.exe. Oh, let's see. explorer.exe-h. Yeah, so this is netcat because I run help on it. You can see that's what it is. Interesting. Why isn't it working? This is where you really just have to play with stuff. 10, 10, 14, 10, 4, 4, 3. PowerShell. There's PowerShell. Still no service being started. Did I misspell the name? No, that's the right name. Am I just starting it from the wrong directory? Is it still set? It's been overwritten again. So let's just see if we can manually do this. So I'm going to try to just run this netcat back to me without the service start. So I'm just troubleshooting it to figure out why this isn't working, because it should work. So that did work. Of course, I'm still Hector, right? But so this means we can actually run netcat from that folder. So that's okay. Our syntax is okay. So what is wrong here? It's like this got rewritten again. Now you can see PowerShell's there. Right, so this actually looks good. You should just have to do start service. Oh, it's looking for the service name. Now we got a shell. I don't know why it worked that time and it didn't work before, but this just shows you why you need to do this. Now, you will notice we are system, so you might think, oh great, we did it, we escalated the system. We did, but the shell is going to die in a few seconds because it's going to be overwritten very, very quickly by the default image path for the WUA serve application. So we don't really have a lot of time. What we can do, and see, it just died. Watch this. See, it's dead. So this is what we have to do in order to get this to work. Set up 443 listener, Control A, and then Shift double quote. And I'm also going to set up NVLP 53 DNS, because that's also a port that's usually allowed outbound in a target organization. And so now we've got 443 and 53 listening. What we need to do is basically we need to do a couple of things, right? We need to quickly run this again, right? Get item property. And let me make this a little bit bigger. We're going to have to replace this image path, and then quickly from this shell, start a new shell to connect back to this shell, so that when this shell dies, we'll live in this process, which is a different process, which is a different shell. Okay? Hope that makes sense. In order for this to happen, we need to pre-build it. So I'm going to go ahead and open up text edit, and I'm just going to pre-build it so we can just copy and paste this thing. So let's grab this. Right, so we want to have this on our clipboard ready to go. Control C. All right, so now what we want to do It's going to be very fast when we do this. Let's go back here. Get item property. We see that our image path is wrong. Set the path to our netcat listener. Confirm that it's correct. It is. Now, we will quickly start the service. WUAU serve. Got the shell. Control-Shift-V. And now we've got the shell as system. So now when this shell up here dies, it won't matter because we'll live in this process down here. Okay, and you can actually see that happen if you wait a moment. It's pretty cool. All right, so now you can see the shell's dead. This shell is still here as Hector, but our system shell is dead. But this one isn't dead, right? We live on. The shell must live on. So that's great. We've gotten to system. Now what are we going to do? Well, next lecture, we're actually going to RDP into the box, and we're going to take a look around the file system, the registry settings, the IIS server, and the logs, so we can look at, the artifacts that we left behind through our attack. All right, I will see you in the next lecture.